right, we're continuing the countdown, just 3 more class periods now, including today. You can see the light at the end of the tunnel, right? Mom making you some Christmas cookies. Get ready to go home with those. I do want to say a word of apology, actually, about this assignment. I think, I was not careful enough in assigning the problems as I should have. I know there were a lot of issues on some problems that caused difficulty. Hopefully not quite as much difficulty as this guy. I only just now noticed that picture at the beginning of chapter 10. That's an awful picture to put in a stats book, okay? Oh, well, yeah, maybe it's great, maybe it's really accurate, and maybe for this assignment especially. What I'm going to do, especially with those last couple problems, 10.13 and 10.14, is I'm going to give you, have the grader give you credit for trying them, okay? I'm going to reassign them for next time as electronic homework. We're going to go over them together in class here. I'm going to assign another one that's also going to be part of your electronic homework for next time. We're going to go over them in class, talk about using the spreadsheet to solve that problem. For future classes, if you don't have the same book, it still will be beneficial for you to go over these examples. Yeah, I should have been more careful in assigning those. I really didn't give you quite enough tools. You really needed the spreadsheet. You did have the tools, technically speaking, but it was complicated enough that it was hard to figure out what tools to use. So we'll go over those questions again. Do I ever feel like this? I do sometimes, even when I'm doing math, but I do feel a lot of joy. I wouldn't be doing math, I wouldn't be a math teacher unless I had a lot of joy doing math. God has given me joy in doing math. I'm sure it's partially because I'm successful, but partially just because I have that kind of personality that I like it. So those probably feed off each other. I hope God does give you joy in doing something, both in the workplace, once you get outside of Bethel, and also here in school when you are learning things and have some success. Whether you've had success in math to this point or not, I don't know, but I hope that and pray that God does give you joy in some areas of your academic studies. All right, so let's go ahead and, well, let's do something else first. We will use the spreadsheet a lot today. I do want to do something else first. I want to re-emphasize some things about the chi-square test. And then we'll go back to looking at regression. I want to emphasize what you did for the first exercise, 9.9, which, though new, should have been not too bad, I hope, by following the directions carefully enough. The relationship between chi-square test for 2x2 tables and hypothesis test for proportions. And for that, we're going to look at the example in the Excel spreadsheet that we looked at last time. Sleep level versus exercise level. These built-in chi-square functions only seem to work in Excel. They don't seem to work in Google Docs sheets, though Google developers, I please ask you that you put those in Google Sheets. Somebody should at some point, I would think. But here, as of December 2015, they're not in there yet. Let's quickly go through the chi-square test for this 2x2 table. Same example we looked at last time, looking at kids and whether they exercise high or low amounts and whether they sleep high or low amounts. To do the test against the null hypothesis of what? What's the null hypothesis for a chi-square test like this?
That there is a relation.
It was a 50-50 chance, I guess, that there's no relationship between the variables. The null hypothesis is that there's no effect, no relationship. The p-value measures the strength of the evidence against that null hypothesis, and if the p-value is small, then we have strong evidence against the null. We have evidence for the alternative that there is a relationship. The null would be that there's no relationship, the alternative would be that there is. Intuitively, again, looking at these data here, it does seem like there's strong evidence intuitively. For the high exercisers, it's about 50-50, the percentage who got enough sleep or not. And for the low exercisers, it's definitely not 50-50. Over 2/3 do not get enough sleep compared to less than 1/3 that do get enough sleep. It seems that we have strong evidence, but the chi-square value and ultimately the p-value gives you more precise evidence, more precise information about the strength of the evidence. Let's quickly go through the calculations. Focus on what I say here. Okay, well, we should probably make some totals here. Let's use Excel, which we use in the same way as the Google Docs spreadsheet, pretty much here to do various things. For example, we want to total up the rows. I can do equals C7 plus D7. Zoom in as you need to here with the camera. To add up that first row, I can copy and paste that down to add up the second row. I need to retype a formula to add up the numbers in the column, like that, C7 plus C8. I can copy and paste, click and drag that over here to add up that column, and in fact to get the total of 656 people overall, I can continue copying and pasting. I want to fill in these corresponding cells in the expected chart. I can use that formula without thinking about the meaning of, for each cell, take the corresponding row total and column total and divide by the total number of kids overall, 656 here. Unfortunately, you can't really copy and paste these formulas because the pattern in how you pick the numbers is not consistent. For example, in this upper left cell, that's the first row and first column. Take this column total, oops, use parentheses though. This column total, actually we don't need parentheses, but I'll use them anyway, times this column total, divided by the total there. It's in the upper left, so you take, that's the first column and first row, take the total in the first column, times the total in the first row, divide by the overall total. Again, copy and paste is not going to work here. This is the upper right, take the second column total times the first row total, divide by the 656, again the overall total. Did it do that? Nope. Divide by the 656. This is the lower left, first column, second row, take the first column total times the second row total, divided by the total overall again. And finally, for this one, that's in the second column and second row, take the second column total times the second row total, divided by the overall total again. Okay, these are the expected numbers. What are these telling you? If the null hypothesis was correct, by pooling these two groups, the high exercisers and the low exercisers, to get these numbers, you'd have your best estimates for the proportions of people overall who get enough sleep or not. That divided by that, 266 divided by 656, would be your best estimate, if the null is true, that high and low exercisers get the same amount of sleep overall for the population proportion of people who get enough sleep, 266 out of 656. That ratio, which is what, in the ballpark of, I don't know, maybe 40% or something, just a wild guess, not a real wild guess, would match the ratios of these numbers compared to the totals, 299 and 357. 121.2 divided by 299, I'm not bothering to put the 299 there, and 144.7 divided by 357 should be the same ratio, and it should match the 266 divided by 656. That's the idea. I'm pooling the samples together to get my best estimate for the equal population proportions if the null were true. Once again, the chi-square statistic is a way of measuring the differences between these two tables, essentially. I'll do it all at once here. Take each observed value minus the corresponding expected value squared divided by that corresponding expected value. And there's going to be 4 terms in here because there's 4 cells in each table, 4 main cells. Add on, go to the next cell here, use parentheses. Here you do need parentheses, by the way. Take that observed value minus this expected value, square it, divide by the same expected value again. Zoom in there with the camera to see those things. I hope you're following where I'm clicking here, paying attention. This is where you got to work hard to pay attention. Then take this one minus this one squared divided by that same expected one again. Then finally take this one minus the corresponding one over here squared divided by that expected one again. That's the chi-square statistic. It's fairly extreme here, fairly large. That's going to lead to a small p-value. You can do the p-value in 2 ways, equals chi-dist. Allows you to just take this chi-square value, the 22.577 here, in cell C11, then put a comma for the degrees of freedom. R is 2, C is 2, 2 rows, 2 columns. R minus 1 times C minus 1 is 1 times 1 is 1. There's 1 degree of freedom here. This will give that p-value. It's pretty small, scientific notation, 2.0188 times 10 to the negative 6 is what that means. Alternatively, you can do equals chi-test instead of chi-dist. And there you don't need the totals or the chi-square value. You just highlight the actual numbers, put a comma, highlight the expected numbers. Okay, so that's less work actually. You still need to calculate the expected numbers, but you don't have to calculate chi-square. Same p-value. This is also related, and you have this homework problem about this, to tests for population proportions. When you've got a 2 by 2 table, if we focus on, say, P1 being the population proportion of all high exercisers, above average in exercising, I guess it was above the median actually, that get enough sleep. Top proportion of high exercisers that get enough sleep. And we let P2 be the population proportion of low exercisers that get enough sleep. The only difference being the word low there. Do we have evidence that these population proportions differ? We can use the sample proportions and do a z-test, as in Chapter 8. And the gist of what we do is if we're doing a two-tailed test, we'll get the exact same p-value. Let's try it. So the null hypothesis is that P1 equals P2. The alternative hypothesis is two-tailed. If we do this two-tailed test in this situation based on this 2 by 2 two-way table, we should ultimately get the same p-value as we got with the chi-square test. We need our statistics. We need P1 hat and P2 hat for the samples. Look at these observed numbers. P1 hat is 151 divided by 299. Those are the high exercisers. What percentage of the sample got enough sleep? Yeah, that's what we were doing. And for the low exercisers, do 115 divided by 357. I'll do those calculations on Excel. Again, this is Excel. This is not Google Docs spreadsheet, although you could do this on Google Docs. You can't do the chi-square stuff in Google Docs. So let's calculate those fractions. 151 divided by 299. Look where I'm clicking. That's a bit bigger than 50%. 0.505. Do the next one. 115 divided by 357. That's less than 1/3. 0.322. Those are different proportions. We definitely have some evidence against the null. How do you do this test? Remember, you calculate the difference, D, if you like, P1 hat minus P2 hat. calculate that difference. 0.182888. And then calculate the standard error for the pooled proportion difference. Remember, this P meant pooled. Why do we pool? Well, remember, when you do this test, you assume the null is true. If we assume P1 and P2 are equal, it makes sense then to pool the two proportions together to get a combined proportion that would be a better estimate of the null value if indeed those two proportions are equal. How could I do that? Well, just take the totals. 266 divided by 656. Oops. E7 divided by E9. That'll be the pool proportion of all the people's high and low exercisers that get enough sleep. And assuming the null's true would be our best estimate for that null value. It's not halfway between these two numbers because these are really weighted averages. There's more low sleepers, low exercisers than high exercisers. So it is a little closer to the lower number than it is to the top number, since there's more of the low exercisers. What was the formula for this pooled standard error? Take the pooled proportion times 1 minus the pooled proportion times 1 over the first sample size plus 1 over the second sample size, multiply all that, and then take the square root. Let's do this all at once on Excel. Equals SQRT, that's the square root. Or you can raise to the 0.5 power, ultimately, is an alternative way of doing it. Here's the pooled proportion, P hat, times 1 minus that pooled proportion, times what are the sample sizes? High and low exercisers, 299 and 357. 1 over 299 plus 1 over 357. If you use parentheses in the way that I'm doing, it should work correctly. Order of operations, you'd want to figure out these fractions first. Then you'd want to add them. Then multiply times these numbers, and you'd want to get that difference before you multiply. You can do it all at once on your calculators too. Ultimately, taking the square root at the end. There it is, there's the pooled standard error. What's the z-statistic? P1 hat minus P2 hat divided by that pooled standard error for the difference. D means difference. So now just take, where is the difference? It's right here. Where is the pooled standard error? It's right there. There's the value of z, 4.75. Here's something interesting. If you square that value of z, guess what you get? Do you remember from the reading? You read about this, you thought about it in that problem, that very first problem. Do you remember what you get when you square the z value here? You get the chi-square value. You're going to get 22.577. These things are related, that's the point. 22.577. And the other point is that the p-value for the two-tailed test here is the same. It's a two-tailed test, I've got to double the one-tailed p-value. I use a normal distribution, a z, to calculate the p-value here. So on Excel, and this works on Google Docs as well, I can do NORMDIST. What's x? That's really z, 4.75. What's the mean? What's the standard deviation? That's 0 and 1. This is a z. It's a standard normal. 4.75, comma 0, comma 1. Is it cumulative? Yes, although I'm realizing I'm not going to get the right answer by doing this. I got to do 1 minus that thing. Because I'm remembering now, cumulative gives you the area to the left of a number. We want the area to the right. Otherwise, I have to put a negative E16 in there, I suppose. NORMDIST gives you an area to the left. We want to take an area to the right, which will be small, and double it. We want to do 2 times 1 minus the area to the left. This should be the same p-value, 2.01884 times 10 to the negative 6. And it is. Okay, matches the chi-squared p-value. Okay? So again, the point is, and you should know this for the final exam, that these things are related when you're doing a 2x2 two-way table. When R is 2 and C is 2. These two tests are very much related. You can do the same test either way. For bigger tables, then there's not a clean relationship there. All right. What to do next? Let's start working on the electronic homework now, which will be redoing those problems 10.13 and 10.14. You can open and look at those problems. They're on page 544 and 545, if you want to look there. I will also add another problem to this electronic assignment. It's going to be a fairly long one. I'm not sure I'm going to have time to do everything completely on the spreadsheet and answer every question, but we'll at least talk about every part. I'm sure I won't finish before quiz time. Okay, so this will go over into lecture B as well. I did download the data, and part of the pain of this assignment was just typing in that data, right? You had to type it in. Well, now I'll share it with you. I downloaded it. So 10.13 and 10.14 are about home sales. Turn this off might help you see it. Does that help you see it? Better? Significantly better? And it's not real bright there. We are now in Google Docs sheets. It's going closer. I know it's the end of the semester now, but the book does have a companion website where you can download these numbers. And that's where I found this. For future semesters, hopefully I'll remember to say that earlier. Okay, so property number, that's just a label. That's not an X or a Y. The sales price is an X, and the assessed value is a Y. Actually, is that the way they want to think about it? Not necessarily. Ultimately, in looking at problem 10.13, they're wanting you in part C to predict selling price from assessed value. That means we should really switch them around. Assessed value should be X and sales price is Y, even though in the book and here they are in the opposite order. You got to look at the way the problem is phrased. In part B, they say when they make a scatter plot, put assessed value on the x-axis and sales price on the y-axis. That makes more sense intuitively. You would want to think of your sales price as responding to the assessed value explaining the sales price. That would make more sense. It could be the other way around, but that would make more intuitive sense. So I'm actually going to switch these around. This will be a Y, and this one will be X. And we will go ahead and switch these around. Let's see, let's insert a column to the left of that one and copy and paste this one. Cut it out, paste it over here. So now you've got them switched around. Okay? You know, that kind of thing could certainly happen in real life where you'd have to switch them around depending on what you want to be X and what you want to be Y. Okay, let's go ahead and make a scatter plot. As that is something you were supposed to do. Inspect the data. It's probably, and make a scatter plot in part B. It's probably best to do part B before part A, which is okay. Make the plot, then inspect the data. What do they say in part A? How many have a selling price greater than the assessed value? Okay, where you can look at the numbers and just count how many, or count the percentage that have a sales price greater than the assessed value. But it might be nice just to make a plot and look at it. So let's insert a, let's see, do that again. Can we not insert a chart here, or is the chart option? Ah, I thought it was under insert.
It is.
Can I not go down?
Scroll down some.
It's not letting me scroll. Okay, let's try going out further. Now I can see it. It wasn't letting me scroll for some reason. Chart, scatter plot, there we go. You should take the time to label things and make it look nice. For sake of time, I'm not going to do that. Although it did label the axes correctly. Assessed value is horizontal. Sales price is vertical. Probably would be good to label, give it a name, maybe to add a little flavor, something different than what is shown there, though we are looking at sales price versus assessed value. As far as figuring out visually what percentage have sales prices higher than their assessed values, you could imagine drawing in a line y equals x in here. It's a little tricky here. 300, 300 is this point right up there. 100, 100, and 200, 200 are not obviously shown. You could estimate where they are. Maybe right about here for 100, 100, and right about here for 200, 200. This line would be the line y equals x, approximately like that. It's not the regression line, though it does seem to follow the trend fairly well. Maybe a little bit below the regression line. So because of that, if I've drawn it fairly accurately, it does visually seem like most sales prices are higher than their assessed values. Most of the points are above this line. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 21 or so, my line's not perfect, out of 30, about 2/3 of the houses seem to have a sales price above their assessed value. People are wanting more money than the tax assessor is thinking they're probably going to get. There's an intuitive reason why that might happen. Report the least squares regression line. Well, we could have done that with the plot when we inserted the plot, but let's do it the other way, where we're looking at regression output. And this will be good to do as we review briefly for the quiz with it, because you need to be able to read this output for the quiz. Remember, you've got to go to the XLMiner add-on. If you don't remember how we got this, you'll have to look at the video from 2 classes ago. The Tuesday before Thanksgiving. XLMiner Analysis ToolPak. Go to linear regression. The Y range, and highlight that. Click on this box that says input Y range. Shows up. Now highlight the X range. I'm including the label, by the way. Although when doing that, I want to make sure I click this labels box. That's usually the first thing I do, is click the labels box to remind myself of that. Now all we need is an output range. Oops, not there. Like, for example, down, well, how about right here? The upper left corner of the output. And let's go ahead and see the residuals in the residual plot, though that's not on the quiz. Click OK. There's the summary output for regression. What have we talked about here so far with this? That thing's the correlation. That thing's the square of the correlation. The word multiple R means something different in multiple regression. We're only doing single variable regression. Ignore adjusted R-squared. This is the standard error for the regression, which in chapter 10 is called S. It's not a standard deviation, though it's a similar idea. It's an estimate for a standard deviation in the population, in the regression model. It's not a standard deviation of X or Y, I should say. We call it the standard error for regression. There's N. We're ignoring the ANOVA part for the moment. Go down here. Those numbers, there's the intercept. It's labeled with the word intercept. That's B0. There's the slope. It's not labeled with the word slope. It's labeled with what X is, assessed value in this case, which is a good idea in general. It's a good idea to, especially when you do multiple regression with more than one explanatory variable, to have the name of the explanatory variable be what goes there, and then each number next to each explanatory variable is kind of like the slope for that explanatory variable. Probably better to call it a rate of change. It's a slope in some higher dimensional space that you can't imagine unless we just do one more dimension. Probably best to call it a rate of change. But here, that's the slope of the regression line, so you can find the equation of the regression line from these things. After the quiz, we'll also talk about the meaning of these other things. So let's stop at the moment and take the quiz.